following statements is an inaccurate statement about thermodynamics? So, and we have A, B, and I think C here. Says ionic solids with weaker attractions have higher entropies than ionic solids with stronger attractions. Let's skip that for a minute. Let's talk about B. It says B, product favored reactions require continuous outside intervention in order to produce an appreciable amount of products. Let's come back to that one too in a minute. We'll talk about that. C, Gibbs free energy is energy that is available to do work. That is true. That was the easy one. Now let's talk about A and B. So let's go back to B. Product favored reactions require continuous outside intervention in order to produce an appreciable amount of products. So the way that I break this down, continuous outside intervention means, so non-spontaneous, while product favored reactions means spontaneous, right? Because product favored reactions are going to make products. And so if spontaneous reactions require them to be non-spontaneous, this is the one that's inaccurate or false.
Professor, I have a question.
Go ahead, Willem.
Are you recording the video?
Yes, I am.
Okay, thank you.
Sure. Now let's come back to A. Ionic solids with weaker attractions have higher entropies than ionic solids with stronger attractions. Well, we haven't talked about this, but let me see if I can take you through it. So ionic solids with weaker attractions, and for A, let's talk about NaCl versus NaI. Of these two, let's see if we can keep everything on screen there. There we go. Of these two, can you tell me which of these ionic solids has weaker attractions or weaker ion-ion forces? Sodium chloride or sodium iodide? Let me help you a little bit. So we talked about this when we talked about intermolecular forces. Both of these are +1, -1s. And this ion-ion forces things comes back over and over again, even in physics classes.
Is it iodine, Professor?
Yes, thank you. This one will have weaker, right?
Mm-hmm, because they'll be further away.
Because they'll be further away. And if they're further away, then they will be more dispersed. And have higher entropy. And so this takes two seemingly disparate topics and puts them together. But it turns out that it is a true statement. And if you see this question on the homework, you would say, well, B, although this is a very wordy problem, I will say, but B is pretty false, pretty inaccurate. But yeah, it's a tough problem. Any questions about this? And this is, by the way, one of the processes that I do when I have a hard time understanding something. Like, I don't know how entropy relates to ionic solids with weaker attractions or not, but that's when I put it into some sort of example that I have a little more like familiarity with. And then all of a sudden you realize that size does matter for ion-ion forces. And then all of a sudden things click. That's the goal anyway. Well,